We'll proceed in vector and energy calculus. Vector and commercial calculus. Vector or and energy calculus. Both are same. Either we say commercial calculus or you say energy calculus. Vector and energy calculus. Now we are in a phase to prove that Earth gravitational pull is path independent. Earth gravitational pull is path independent, and we have proved that Earth gravitational pull is path independent. There are two ways to prove Earth gravitational pull is path independent. One way is that with under Earth gravitational pull, whatever the force is, if this is Earth, okay, if this is Earth and any particle is moving toward the Earth, consider that it is moving in a circle. How it can move in a circle? In a fashion that if I place this particle here, I pierce the particle here. This is down is Earth. If I leave it, it will fall like this and it will come back to this location. Okay. Now, how much is the energy imparted by the Earth? If that is the case, then this is Earth gravitational pull. Under the Earth gravitational force, one item from that is pierced here, bolt. This is what I say, a bolt. Bolt has a hole. Now I place the bolt inside this. Bolt has a hole, and I place bolt inside this. Now I close this. Now, if I leave this, bolt will immediately it will fall like this, and then it will go up like this. Okay, under this gravitational pull, if energy now the Earth is energy source, how much energy Earth liberates when our particle is moving from here back to here? Earth, since it is moving from here to here, under Earth gravitational pull, there is energy consumed from the Earth. Earth as energy source. When it is moving back here, then Earth, energy consumed by Earth in other direction. Earth gains the energy. Net energy transferred by the Earth is zero. No energy. Because it is path independent. Why it is path independent is energy is nothing but force into displacement. There is no displacement. Item moved from here to here, came back here. No displacement. If there is no displacement and force is path independent, energy source is path independent, then no work done. Work done is zero. But if it is path dependent, then there is work done. And work done, whatever the energy source is losing when there is a work done. If this is energy source and this is force field of energy source, one item is moving from here to here, there is this energy source is losing because item is moving from here to here, means there is a kinetic energy involved. That much kinetic energy this item is getting from here to here, that energy is lost by this energy source. How much energy is lost by the energy source dependent upon the path, because it is path dependent. Path independent means only begin point and end point. Path dependent means begin point, end point, and the path along it. If path is very short, that is straight line, then this energy source is liberating is very less. If it is circular, elliptical, more displacement, if we go, then energy lost by this energy source is more proportional to the distance. So one way to calculate then what is the nature of this energy source, how much it is path dependent, that we are calculating. One way is in a closed loop, calculate the energy divided by the area. Another is calculate the torque factor or curl factor of the gravity of the force field of this energy source. If this is energy source, this is force field of the energy source. If this is force field of the energy source, then dF2 force is the capital F is the force field of energy source, then capital F equal to F1I plus F2j. If this is force field, this is x axis, this is y axis. If this is force field, then this is F1, x component of F. This is F2, y component of F. What is dF1 by dx? Sorry, dF2 by dx minus dF1 by dy. If both are same, equal to 0, means the curl factor, the torque tendency of this earth of this energy force field is not producing any torque. Torque means if I take any item and it is going toward the energy source, item should go straight forward. It should not rotate. If this is item, then it should not rotate while going to the energy source. Okay, it should go straight forward. That is path independent. Path dependent means it is making a curve. So there are two ways we check item is path independent or not. One is under this energy source there is a force field. Under this force field, make an item move from one point coming back to the same point. Calculate the energy involved in that, divide it by the closed loop area. Okay, so that if that is zero, if that is zero, then it is path independent. If it is not zero, then how much it is? That is that talks about the circulation density or nature of this energy. So how much is it path dependent? Or calculate the curl factor df2 by dx minus df1 by dy. If it is zero, then it is path independent. Means if any item is moving toward the energy source, it is making curl or not. This is another measurement that is path independent or dependent. If it is not making any curl going straight forward, like if I drop this, no curl, earth is path independent. Otherwise, if it is rotating, then it is path dependent. How much it is dependent? Dependent, that is df2 by dx minus df1 by dy. That is called curl factor and it is same as circulation density. Energy in a closed loop divided by the area. Okay, now we through both measurement, through curl factor and through circulation density, we found that our Earth is path independent because curl is zero and circulation density both are zero. Okay, now against the force field is minus gmr vector divided by r to the power 3. Consider there is a force field called minus yi plus xj. The force field is minus yi plus xj. This is the force field. If this is the force field, then this is path dependent or independent. Consider this is the force field of the earth. The earth force field is this is this is earth and its force field is minus yi plus xj. Can you just make a diagram what it is? Yes, certainly will do. This is x-axis, this is y-axis. Now when we talk about the force field minus yi plus xj, when on the x-axis y is 0, in that case it is xj. More we go in x direction, xj will be more powerful. It will be like this, xj. If I come on y-axis, minus yi plus xj, x is 0, minus yi means in this direction. So it is like a circular direction this vector is, minus yi plus xj. If that is the case, then it is this. This is the force field of Earth now. Earlier, the Earth force field was minus gmr vector divided by r to the power 3. Or someone can take xi plus yj plus zk. Now the Earth's gravitational pull is minus yi plus xj. If that is the case, then tell me the Earth is path dependent or independent. Okay, let's calculate through the circular fashion. Take a circle and calculate the net work done, net energy involved making item move in a circular path. Okay, energy computation is F1 dx plus F2 dy, force vector dot d of position vector. Force vector is minus yi plus xj. Position vector is xi plus yj always. Because if I take any point x comma y connect from the origin, then this position vector is xi plus yj. Okay, so d of xi plus yj minus yi plus xj dot d of xi plus yj. If someone does this, settle this, it becomes minus y dx plus x dy. Integration, this integration x from minus a to a. Okay, now I am free to kind of choose polar coordinate. That would be, I believe, I can try in the Cartesian coordinate only. Minus yi dx plus x dy. If it is circle, then y equal to square root of a square minus x square minus square root of a square minus x square dx plus plus x dy. Dy is nothing but dy by dx into dx. So dy will become minus x by square root of a square minus x square dx. If someone settle it down, it becomes minus and in bracket a square minus x square minus x square. It will become minus a square. More or less, it becomes minus a square. Minus a square I can keep outside and it becomes 1 by square root of a square minus x square dx. Integration of 1 by square root of a square minus x square is sine inverse x by a. Now sine inverse x by a. X is minus a to a. If I put a there, then it becomes sine inverse of 1 pi by 2. Pi by 2. If I put minus a, then it becomes sine inverse minus a minus 1 minus pi by 2. It becomes pi a square. Pi a square is outside. Pi a square. Okay, I took x and y in a sense that it is centered at the origin. The first half only we have taken. If I multiply by 2, then it becomes 2 pi a square. 2 pi a square. If that is the case, then divide it 2 pi a square is the energy involved. Leave it circulation density. Energy is there. If Earth gravitational pull is minus yi plus xj, minus yi plus xj. If that is the Earth gravitational pull, minus yi plus xj, then the energy, if this is the Earth, if item is moving from here and coming back to here, Earth is losing energy somehow because force field is xi minus yi plus xj. How much energy it is losing? That is pi 2 pi a square. 2 pi a square minus is there. I am just leaving it. Pi a square. Pi a square. That is the energy that Earth is losing when item is moving in a circle of radius a. Pi a square. Pi a square 2 pi a square divided by the area of the circle. That is pi a square. Took gone 2. 2 is the curling factor. Density is the circular density is the measurement of energy source. How much it is path dependent? It is path dependency is 2. Okay, let's calculate through the curl way. How much curl it will if if Earth gravitational pull is minus y plus xj, then if item is falling towards Earth, it will start rotating. Then it will fall. while while falling, it will rotate. So that is df2 by dx minus df1 by dy. df2 f2, the gravitational pull is minus yi plus xj minus yi plus xj. F1 is minus y, F2 is x. df2 by dx minus df1 by dy. 1 plus 1, 2. 2. 2 is the curling factor here also. So Earth is not path independent if Earth gravitational force pull pull is is minus yi plus xj. Makes sense? Okay. So this is the computation of how Earth is path independent or not. Now talk about the force field, path independent or not. If it is path independent, what is the extent? If curl factor is very high, consider the curl factor is very high, means it is hard path dependent. Hard. Curl factor is 0.0.0000001, means it is path dependent. Little bit it is path dependent. If you change the path from one point to another point, begin point and end point are same, it is going in a item is moving like this from this point to this point. If it is a straight line or it is a curved line, elliptical line, whatever line, it does not make much sense. Much sense. Does not make any sense, means path independent. Net energy calculation depend upon the begin point and end point only. Path dependent means very little dependent upon the path it is taking while moving. Very little. Okay. So this is the story of kind of path dependent, path independent. Now there is something called kind of uh, zero zero curling factor, zero force field which has zero curling, a force field which has zero curling. Anyway, I know df2 by dx minus df1 by dy, that is the curling factor. Okay, so force field is calculate the force field, that is, okay, my force field is minus yi plus xj divided by x square plus y square to the power 3 by 2. Okay, this is what my path is, minus yi plus xj divided by x square plus y square to the power 3 by 2. Okay, we are trying to calculate curl-free force field. A force field which does not have curl. Many ways we have calculated the idea. Earth's gravitational pull more or less is xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. If I talk in xy plane only, I rotate Earth in a way that gravitational pull is going in xy plane only, considering z is 0. In that sense, it is xi plus yj divided by x square plus y square to the power 3 by 2. Consider now the Earth's gravitational pull, instead of xi plus yj, it is minus yi plus xj divided by x square plus y square to the power 3 by 2. Now calculate the curling factor of this. To calculate the curl factor, we have already talked about. To calculate the curl factor of anything, anyway, someone can try curl factor df2 by dx minus df1 by dy. What is f2 here? f2 is x by x square plus y square plus z square to the power 3 by 2. What is f1? That is minus y by x square plus y square, sorry, there is no z, to the power 3 by 2. Now we know that to calculate the curl factor of a vector, where vector can be dissociated, dissembled in an algebraic equation and a vector, two forms. The curl of a phi into f vector, phi is algebraic equation into f vector, is phi into f vector is curl of f, the phi into curl of f plus 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 kind of gradient of phi cross product with the f. This is what we have seen in the past video. What I'm trying to say, if I'm trying to find the curl free vector force field. If the force field is minus yi plus xj divided by x square plus y square to the power 3 by 2, it can be dissociated in 1 by x square plus y square to the power 3 by 2. This is pure algebraic form into x minus yi plus xj, that is vector form. Algebraic form multiplied by vector form. And it is nothing but algebraic form into curl of vector plus gradient vector of algebraic form cross product with the vector form. That is the how it is, someone can try. It's very simple. If I say phi and f vector can be dissociated in f1i plus f2j. It becomes curl of phi f1 and curl of phi f2. Curl of phi f1, curl of phi f we are trying to calculate. F is can be written as f1i plus f2j. Okay, then someone can, it is same as we are trying to find curl of phi f1i plus phi f2j. That will be d by dx of phi f2 minus d by dy phi f1. If you do the chain rule, if you do the product rule in differentiation, finally it will settle down as phi into curl of f plus gradient vector of phi cross product with the f vector. If I take it forward, then the phi here is 1 by x square plus y square to the power 3 by 2. So it will be 1 by x square plus y square to the power 3 by 2 into the curl of f. Curl of f is 2 minus yi plus xj is 2. 2 by x square plus y square to the power 3 by 2 plus. Now the gradient vector of phi is d phi by dxi plus d phi by dyj, cross product with f1i plus f2j. Okay, if someone is talking like that, then it becomes d. Okay, the cross product here, it will be kind of kind of uh, phi, the gradient vector of phi cross f vector. Okay, it is something like if I take a kind of matrix kind of thing. Top row is I, J, and K. Next row is d phi by dx, d phi by dy 0. Next is f1, f1 that is minus y, f2 that is x. If I take the third column and first row, then it becomes d phi by dx into f2, x into d phi by dx minus minus okay minus d phi by dy into f1. F1 is minus y, so minus minus gone, y. Okay, x d phi by dx plus y d phi by dy. Okay, someone can calculate. I'm not saying that it is difficult. X d phi by dy, x d phi by dx. So first term we calculated what 2 by x square plus y square to the power 3 by 2 plus x d phi by dx. D phi by dx, phi is 1 by x square plus y square to the power 3 by 2. It will become minus 3 by 2. 2x, 2 gone, 3x, minus 3x square, minus 3x square, minus 3y square by x square plus y square to the power 5 by 2. If someone settle it down, it becomes 2x square plus 2y square minus x square minus y square minus 3x square minus 3y square divided by x square plus y square to the power 5 by 2. Someone settle it down, it becomes minus and then x square plus y square divided by x square plus y square to the power 5 by 2. I calculated this much. It is computable. Okay, so this is the curling factor if Earth gravitational pull is minus yi plus xj divided by x square plus y square to the power 3 by 2. Consider Earth gravitational pull is minus yi plus xj divided by x square plus y square to the power p by 2. P is a variable. It's not 3. Instead of 3, now it is p. Instead of 3, now it is p. If it is like that, if you remember one, then we have to proceed in same way. That deliberately I did like this, so it should be easy. So what right now it will be? Earlier, the net curling factor was 2 by x square plus y square to the power 3 by 2. Okay, plus minus 3x square minus 3y square divided by x square plus y square to the power 5 by 2. Now instead of 3 by 2, 3 I am taking p by 2. Then it will become 2 by x square plus y square to the power p by 2 plus minus 3x square. 3 will be p here plus minus px square minus py square divided by x square plus y square p by 2 plus 1 or 3p by 2. Okay, if someone settle it down, then it becomes here 2x square plus 2y square minus px square minus py square divided by x square plus y square to the power p by 2 plus 1. If someone proceed further, then it becomes x square 1 minus p, sorry, 2 minus p, x square 2 minus p plus y square 2 minus p divided by x square plus y square to the power p by 2 plus 1 or 3p by 2. Now we are talking about, is it possible that it will be curl free? Certainly it is curl free. If this curl formula becomes 0, okay, if it becomes 0 only when 2 minus p is 0. If 2 minus p is 0, numerator is 0 and it is gone. If that is the case, then p equal to 2. When p equal to 2, when p equal to 2, when p equal to 2, then there is no curl at all. If p equal to 2, then there is no curl at all. So if that is the case, then if Earth's gravitational pull is minus yi plus xj, minus yi plus xj divided by x square plus y square to the power 2 by 2, gone. Minus yi plus xj divided by x square plus y square. If this is Earth gravitational pull, someone can try in Z fashion also, but whatever it is, this is what right now. Minus yi plus xj divided by x square plus y square. If this is the Earth gravitational pull, then it is path independent. Why we are bringing this? Not necessarily if Earth gravitational pull is minus yi plus xj, that is rotating in circular direction, minus yi plus xj, it is rotating in circular direction. If it is rotating, minus yi plus xj by x square plus y square will also rotate in circular direction. Along the x-axis when y is 0, then it is xj minus yi plus xj, xj by x square, that is 1 by xj. It will be again in this direction on x-axis, and y it will be in this direction. Again it will be radial only. This is mind-blowing famous example. This is not my example. Famous example. Mind-blowing famous example. Not true that always if you say that Earth gravitational pull is minus yi plus xj, then it is path dependent because it is going in circular direction. If it is going in circular direction, force field, then if any item is moving in a circle, then certainly there is a work done because force and displacement are in same direction. So there is a work done. It is not path independent. It is path independent. If I divide it by x square plus y square, it becomes 0 again. Then it is completely path independent. But if p is not 2, one scenario is p is 1, then it is minus yi plus xj, minus yi plus xj divided by x square plus y square to the power 1 by 2. It is path dependent. Or p is 3, then minus yi plus xj divided by x square plus y square to the power 3 by 2. Again it is path dependent. If p is not 2, all are path dependent. But if p is 2, minus yi plus xj divided by x square plus y square by 2 by 2, then it is path independent. So, so a path dependent minus yi plus xj, that was completely path dependent. We made it path independent. It's possible. And this is called curl free vector field. So if Earth, consider any energy source which is minus yi plus xj, all of a sudden we cannot say that this is path dependent. It can never be path independent. It can be path independent for sure. Okay, you have to divide by x square plus y square. Someone tried with something else and he said, no, 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 no. Okay, let us better put now one variable there, p by 2, and try with algebra and set the curling factor to 0. Now someone can try calculating this is through curl factor we set it to 0 and find the value of p. Can someone try to do f1 dx plus f2 dy along a circular path and then calculate and then set it to 0 and then see that I mean force vector dot d of position vector, that is f1 dx plus f2 dy. and then calculate in a circular path. And I could have tried it, but somehow I'm feeling little kind of tired. Okay, so someone can try and see through circulation density and setting it to zero, that what would be the value of P when it will be path independent. Then we will see Stokes theorem. More on it. Mr. Stokes, there is one Mr. Green that we have seen. There is one Mr. Stokes. Okay, Sir Stokes, this is what I would say. Because whatever he is talking, it is certainly very high class. Means if I have a circular, if I have a closed loop, if I have a closed loop, and in closed loop, if I calculate the energy computation divided by the area, then it gives the circulation density, or df2 by dx minus df1 by dy, or someone can go with 3D also. That will be df3 by dy minus df2 by dz I plus df1 df1 by dz minus df3 by dxj plus df2 by dx minus df1 by dyk. This would be the curling factor. Or if curling factor is 0, then this is path independent, whatever it is. Or whatever it comes, that is the curling factor or circulation density. Both are same thing. Now, if this is a closed loop path, if this is a closed loop path, all right, this is closed loop path, there is a closed loop path around my hand. Closed loop path around my hand. Consider this, it is making one area. There is a closed loop like this, and it is making one area. Thus, this area is flat, and this area, if I have an area vector that is perpendicular to this, then that is the circulation density direction, or that is the curl direction, df2 by ds by minus df1 by dy. Consider this is not flat, and this is something like this. Same curve, same curve is there all along, but this inside this area, what it is forming, the closed loop forming area, that area is not flat, it is like this. If it is like this, then df2 by dx minus df1 by dy, that will come as an algebra, and each point here, that df2 by dx and minus df1 by dy, it will have different vector. Earlier, we consider a flat one vector along all the full surface. Now, every moment in the surface, that curl vector will be different. In that, if it is different, then how we can calculate the circulation density? How we can calculate the energy calculation in a closed loop? Okay, so if I know energy calculation in a closed loop divided by the area, that is circulation density. But area is now, the area term is a convex, it is not flat. So there Mr. Stokes comes into the picture. Okay, that is the line, whatever the circulation density you have calculated, integrate it with the surface vector, not surface, because surface is not flat now. You cannot take dx dy, surface vector, and then limit will be the surface full, and then you can find the kind of the line integral, that is the energy calculation, not circulation density. Energy calculation you can get if you have circulation density, integrate it along the curved surface. Okay, circulation density is energy calculation divided by the area. If you have that, integrate it by area. Area is now at a surface vector. Then you get the net energy calculation or line integral. So that we will see at Stokes theorem, and then we'll see how we can proceed, because we have to enter into machine learning, artificial intelligence as far as calculus is concerned. So that we will see. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India